Start now. Hello everyone. We start the third period of the course. What about this section? It is the most important point in introducing RAG, introducing knowledge graph into search. What is a knowledge graph? A knowledge graph is analogous to a network of knowledge. Every node is a concept, the relationship between two concepts or entities. We are equivalent to putting the document. It's a network of connections. This way, the answer to the question will be more accurate. This is what we do with knowledge graph. A major reason. What is a knowledge graph? For example, first, the node. Nodes are usually entities. Tim Cook. This is an entity. Is human. Then the company. Apple is the company. iPhone a product. What is an edge? An edge is the edge between 2 points. This line between the 2 points connecting it. Usually a relationship, like the CEO of Apple. What is the connection between this Cook and Apple? This is CEO. This is the product relationship. The relationship between Apple and the phone is a product. In that case, and we build a graph like this, or more commonly known as triples. These two nodes add a relationship. Why introduce this graph? Why introduce knowledge graph in RAG? It's basically vector search. It must search for this. Your question is exactly similar. Such a paragraph. But if they are not similar. For example, I search for Apple CEO. But what? Might not find anything iPhone. But if such a connection is established, we can put this string of things. All relevant documents are given to it. This can answer some questions. Is relative to. It's going to require some pretty sophisticated reasoning. Typical example. Tell me, where did the Apple CEO graduate from? But there may not be a document specifically to introduce. Which universities did Apple's CEO graduate from? But if it is, the first is who is the CEO of Apple? Just know this guy. What about this guy? Which school did you graduate from? Two-layer relationship. If there is a knowledge graph, it's very easy to answer. Such a complex issue. And that's really one of our goals. Of course, the most important. It actually builds a mesh. Diagram of a document. What about our answer? Will be more accurate. What about another one? How to build a knowledge graph. And how is knowledge graph used in RAG? Use the knowledge graph directly. As a traditional knowledge graph. Just like this Neo4j. I searched for who is the CEO of Apple. He reasoned like this, over and over again. Here's how it works. This is traditional, directly deduced from the graph. But now, usually we use a hybrid. That's why. Often the problem is not that simple. Put the relevant documents, document fragment, linked to each knowledge graph node. It's called hybrid. Find the node first, then put the node on. It's like iPhone. Articles related to it. Related fragments. Like this one. We just saw something like this iPhone. We may call the pieces are linked to iPhone node. In that case, not only can answer which company iPhone product and answer all iPhone relevant questions, or when I asked how Apple's products were, he can iPhone all the files, can be summarized, or do some reasoning, rather than just knowing Apple products are iPhone. So let's say now, it's basically all this hybrid, or in short, is to chunk the document, link to, at each node of the knowledge graph. In that case, our search still has this kind of execution, would be more accurate. It's richer to be able to answer questions. And then, according to this feature we just talked about. In fact, how does it work? In fact, it is relatively clear. First, I usually have such a query. According to the query, for example, just now this question, Apple CEO, what university did he graduate from? We will replace the CEO of Apple, who associated his downstream node with the document. This chunk, get all, including the upper and lower layers. We can speculate based on relationships. How much does it need to extend upwards? It needs to extend a few nodes down. This is traditional graph reasoning. Then, take all these fragments, combined with the content of vector search. Then they are all sent to this big model. And the big model will answer those questions. Is equivalent to, we don't just have vector search. Obtained similar documents. Something else. That is, the upstream and downstream concepts are related, and the big model is given. This way, the reference will be more accurate. This is what we have in RAG. A basic idea of using knowledge graph is equivalent to, we retrieve from this simple information. It's intellectual inference. This is one of our key characteristics. The following. So this is just some of the stuff. A summary of the relevant process. Everyone just needs to know. The core is to put linear. This information retrieval. It's mesh. Graph reasoning. That's basically enough. Here are some main applications. What about our app? And here's the thing. You can take a look. We basically, and the idea is the same. That is to say, it is the same as the traditional knowledge graph construction method. The first step is to start with a document. Extract triples. It's our node, the relationship between two nodes. The second step, it's like we put this document. Because a lot of relationships are drawn. Each document may have drawn hundreds. There are hundreds of documents that need to merge this relationship. Many relationships are the same. What about some relationships? It may be connected up and down. They form a network. The third step, it's just clustering. Community discovery. Some may be subordinate to a concept, like iPhone Apple. That might count as a group. Call the community. It's about 3 steps. What about these 3 steps? And our traditional way of building knowledge graph is exactly the same. Take a look at this. This is what we extract. This is the document we added earlier. And remember, this is the document ID. Then extract it here. It's like doing this knowledge graph. Just this step. Extraction of triples. And it's a merger, actually. There's a lot of documentation. And historical. Then merge it together. Just do this second step. Form a network. Then, the third step is, sure, I can take a look at this entity. Let's start with a statement. This cannot be repeated. Because after it is executed once, it has been indexed. Including this, it has been indexed. The table has been built to build this network. Just do it once. We will see the results later. This ID has not been copied yet. This is false. Because we have already established it once. You can use this directly. Take a look. This is the name of our entity. Name Tongji Qinwen. The name of such a large model. That's the description of a relationship. The back is actually a description. The definition of this entity is introduced. Below is a relationship. Let's take a look. Pick one at random. Everyone can let it out. You can run by yourself. So here are 2 nodes. Subjective objective. One is DeepSeek, an open AI. And this is one of their relationships. It's a contrast. This is a relation. Typically the subject-object. It's a directional relationship. Compare to. This is part of community discovery. Of course. Because we may have less documentation. We didn't find a community like this. You understand the big model. How does it work? Knowledge graph. It is actually the same as the traditional knowledge graph. Just might say, when we do this relationship extraction, large models may be used. More specific in the next section. Let's find out. This whole generation process will do, roughly speaking. First, start by parsing and extracting triples from each document. Then what about these triples? Merge triples extracted from different documents. Form a network. What about another one? Is to do some of this clustering or community discovery. This whole. It's code for a corresponding API. That's it. Extract first, then merge. At last, we can do community discovery. This is actually, you need a lot of documents to have it. Community. Then when we use it, let me show you, can be searched. When searching, because we are now the default, if you are based on this collection, such a graph has been created. It will be used automatically by default. You don't make any settings. If this collection, our default collection now is 0. If you have this knowledge map, spectrum, he will use the relevant knowledge graph by default. This does not need to be set up. If not, he doesn't need it. If anything, he would use this knowledge graph. Take a look. There are also many search results. Inside this, one of its graph searches, a search result for. You can see it very clearly. How does it use this knowledge graph? Okay, that's it for the class.